Hello everybody, we're getting ready to do lesson 1.2 for pre-algebra math today. And for today's lesson, it's going to be about powers and exponents. You got 24 points on your notebook. We'll go into your notebook and 39 points on your classwork sheet. Have that out in front of you. Students, put your name, date, period here. And onliners, homeschoolers, put your due date there. We're going to go into our homework, or our bell work, sorry about that, or bell work for the day. Teachers, students, everybody, you got these two here. Write a variable expression for a length of time in minutes if you know number s of seconds. And then number 2 down here, evaluate the expression x minus y when x equals 12.8 and y equals 4. So teachers, give your students about 2-3 minutes. They should knock this out. Pause your video. Okay, welcome back everybody for today's solutions of today's bell work. Up here, write a variable expression for a length of time in minutes if you know the number s of seconds. So how would you write that? B would be this one here, because there are 60 seconds in 1 minute. The number of minutes is equal to s over 60. And then down here, x minus y, 12.8 minus 4 would be 8.8. So it would be G right here, 12.8 minus 4. And this would be your plug-ins here, 12.8 minus 4 equals 8.8. Onward into this lesson. Before, you multiplied whole numbers and decimals. You've done that. Now, you'll use powers to describe repeated multiplication. Why? So you can find the total number of emails. That would be one way that you could use this skill, as in example 29 in your homework. So in your notebook here, a power is the result of a repeated multiplication of the same factor. For example, the number 125 is a power because 125 equals 5 times 5 times 5. A power can be written in a form that has two parts: a number called the base and a number called the exponent. The exponent shows the number of times the base is used as a factor. So 5 to the third power is the same thing as 5 times 5 times 5. So you multiply 5 times itself 3 times. And that would be the exponent right here, your 3. And then the base would be your 5. And then the whole thing is a power. So this whole thing is called a power. And then here's your factors here. 5 times 5 times 5. The base is 5. The base 5 is used as a factor 3 times. So that is a breakdown of an exponent. So what do we got here? The table shows how to read and write powers. Numbers raised to the first power, such as 12 to the first power, are usually written without the exponent, just as a primer here. So here's our power column, words, in words column, and then value column here. So 12 to the first power, 12 to the first power would equal 12. And then 0.5 squared, or to the second power, be 0.5 to the second power, or 0.5 squared. And 0.5 times 0.5 would equal 0.25. And then 4 to the third power, or 4 cubed, this would be the same thing as a cube. 4 times 4 times 4 is 64. Then 8 to the fourth power would be 8 times 8 times 8 times 8, which is 4,096. So here is a good example here of how powers are used and what their values are. Okay, students, here's your chance. Define power, define base. 10 points here, so big points here on your definitions. And then define exponent as well. And we go into our first example here. Example 1, using exponents. Write the product using an exponent. So 13 times 13 times 13 times 13 equals what? So write this product as an exponent. How would you do that? 13 to the 4th power. The base 13 is used as a factor 4 times. And then for b here, 0.2, 0.2, 0.2, 0.2. How many times is that used? 0.2 to the 3rd power. 0.2 is used as a factor 3 times. Extending out here for example 1, write the product using an exponent. So we have n, 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 n. So I will rewrite that as an exponent. N to the 6th, the base n is used as a factor 6 times. And then t, 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 and t. That would be t to the 5th. The base t, this would be your base, is used as a factor 5 times. Okay, so our first guided practice here. Write the product using an exponent. So there's our first issue there. Then students, this is yours. Do that one on your own. We'll go ahead and do the guided practice. Write the product using an exponent. So 4.3 times 4.3 be the same thing as 4.3 to the 2nd power. Okay, example 2, evaluating powers with variables. Evaluate the expression next to the 4th when x equals 0.5. So x to the 4th would be the same thing when we plug in 0.5 for x. We get 0.5 to the 4th power. Substitute 0.5 for x. 0.5, 0.5, 0.5, 0.5 as a factor of 4 times. What does that come out to? So 0.5, it would come out to the 4th power be 0.0625. Okay, evaluate this expression when m equals 3. So we'll plug in there. Students, this is yours down here. We'll do this one here as our guided practice. So for this one, evaluate the expression when m equals 3, m to the 5th. So we plug in here, m would be what now? 3 to the 5th power, which is what? 3 times 3 times 3 times 3 times 3, which is 243 for this expression here. This expression here, 3 to the 5th, is 243. A formula using formulas describes a relationship between quantities. Some formulas involve powers. For example, you can use a formula to find the area of a square or the volume of a cube. So SS, this is the area A of a square. So it would be S squared would be the area of a squared. And then here we have what looks like a cube, volume V of a cube. Would the volume be S cubed here? Area is measured in square units such as square feet or square centimeters. Volume is measured in cubic units such as cubic inches or cubic meters. So when measuring volume is different than finding area. Using powers and formulas. Ice sculpture. An artist uses a cube-shaped block of ice to make an ice sculpture for a competition. Find the volume of the block of ice. So here's our volume here, 20, 20, and 20. So how would we find the volume of that block? Use the formula for the volume of a cube. So volume equals S cubed. Write the formula. Here's our formula here for this. So we plug in for that. Our plug-in would be plug in 20 there for S, so 20 cubed, substitute 20 for S. And when we do that, we get 8,000. So 20 cubed be 8,000. So the area of the block of ice is 8,000 cubic inches when it has these dimensions here. Okay, find the area of a square with a given side length. We have 0.5 centimeters. Students, this is yours down here. Find the area of a square with a given side length. So for this one up here, 1.5 centimeters, what would be the area of a square with a side length of 1.5 centimeters? So S equals 1.5, area would equal S squared. And so it'll be 1.5 squared, which is 2.25 square centimeters. And that is 1.2 pre-algebra math, animated PowerPoint math video at AOL.com for materials or questions. Thank you.